All right, hi guys. Thank you for being here. I apologize for my voice. I am sick, so my voice is a bit off. I don't know if you guys can hear. So yeah, your final exam is getting closer, your paper 1. So I thought that today we would look at November 2021. We would look at the functions questions and the calculus questions. So on the last live on Tuesday, we did question 4.1, which was a functions question, which was about hyperbolas. So I'm not going to redo that part. I did post that on my YouTube channel if you want to go take a look at it there, if you want to go watch that. It wasn't a very difficult question, and we did go through that in the last live. So now today, let's look at 4.2. So just to catch everyone up, we're looking at the November 2020 paper, and if you were in my last lives, then you would know that when we get a question, I go through the question, but I also explain things. I also explain how you would find the answers and so on. I don't just do the question and then that's it. All right, so 4.2, we can see here it is matric work, but some of it is also covered in grade 11, so it's not all matric work. All right, guys, so question 4.2. You can see that they've given us some information about these graphs, and they've also given us the diagrams of the graphs. Now, what a lot of people do when they get a question like this, I know that some people struggle to finish the exams, so you do want to get going as quickly as possible. You want to just, go into the first question and answer it, but it actually helps so much if you just take a breath and you just read through all the information that's given and actually also write it down. Then once you've written some things down, you can actually... Hi Ashton, no, you haven't missed anything. We've just started now. So like I was saying, if you start with a question, you want to actually read through everything that's given clearly. You want to make some notes on the actual paper, and only then, once you have made sure that you know what's going on, then you will actually start answering the questions. All right, so for 4.2, they've given you two equations here. They've given you the equation of the graph of f of x, and this is a half times x plus 5 squared minus 8, and then g of x, which is a half x plus 9 over 2. I'm just seeing your question now. Yes, you can do the questions in any order. You just need to make sure that you label them properly. All right, that's very important. You have to make sure that you number them properly, actually, is what I'm trying to say. All right, so if we're looking at this equation and at the graphs that we have, then it should be clear that this is an equation of, or the equation of a parabola in turning point form. Yes, this is the last year. This is 2020's paper, yeah. So this is an equation of a parabola, and this is an equation of a straight line graph. Now, when you see these two equations, it is important that you know what these things actually mean. So if you're looking at this equation, you need to recognize that this is turning point form. All right, which means that we can find the turning point from looking at this equation. Just by looking at it, we should be able to know what the turning point is. And then this obviously is a straight line equation. So what I'm going to do, and I even do it when I'm working through questions myself. I've been teaching for years, but it still helps me also just to get clarity of what is actually going on. So for 4.2, I'm going to write f of x is equal to... Sorry that it goes a bit blurry when I'm writing. How many formula can you use to get turning point? You can use whichever formula you want, basically, but I'll show you now when it's given in... How many formula can you use to get turning point? You can use whichever formula you want, basically, but I'll show you now when it's given in... Did I lose you guys? Are you still here? Okay, jy hoef nie te bly nie, bye. Okay, so this is turning point form, meaning that I'm just going to write turning point form. Y equals a times x minus p squared plus q. Yeah, no, sorry, I actually got... Yeah, I don't know why the network is so bad. Let me quickly try to switch the Wi-Fi on again. Sorry guys, it was fine, of course, just until I started trying to broadcast. Wi-Fi on again. Sorry guys, it was fine, of course, just until I started trying to broadcast. Another number there, it might just be 1. If you have a bracket squared, then the number in the bracket, that will always give you the x value of your turning point. So if it's written in this form, then the turning point is positive P and Q. Right, now I want you to notice that in this bracket it's actually x minus P, but in the turning point it's positive P, and that will always happen when a parabola is written in turning point form. The sign in the equation will always be the opposite sign from what the x value in the turning point, in the coordinates actually is equal to. So if we're looking at this, we have x plus 5. That means that the x value of the turning point is going to be negative 5. Hi Katie, I'm glad you're here. I'm also having some issues here. Yeah, that the connection might be bad because of load shedding. I'm not sure. All right, so here the turning point is going to be negative 5. And then the y value of the turning point is just that number there. So negative 5, negative 8. Okay, so that is the turning point. Now, guys, we've recognized that without even looking at what they're asking. All right, and that is useful. If you just do a quick scan of the information that's been given and you just write some stuff down, then that could be very useful. Obviously, it's taken us longer now because I'm talking and, things are happening, but it will save you some time if you just kind of get your frame of mind. You just kind of, what's the word that I'm looking for? You just first figure out what's going on. Okay, so now here we know that, okay, this is turning point form, that's the turning point. Sorry, I'm a bit distracted, but I'll be fine just now. Okay, this is the straight line equation. This is standard form. We know that standard form of a straight line equation is y equals mx plus c. You learned this in grade 9. We know that the m value is the gradient, and we also know that the the y-intercept is your c value. Okay, so c is always your y-intercept, so that means that the y-intercept here is actually going to be 9 over 2. So I'm just going to write that. We might use that at some point. Okay, let's look at the picture as well, because now they're saying they've given us the equations, and now they're actually giving us some information about the graphs. They're saying that A is the turning point of F. Now, if we're looking at the picture, A is this point down here, right? Now, A is the turning point. We've already written down that the turning point is negative 5, negative 8. So, guys, once you know that, fill it in on your picture, right? You can use your paper in whichever way you want. If you want to write all over it, that's perfectly fine, okay? So, we are putting the coordinates down there. Now that helps us already, okay, because now we can see that they've put a straight line here. But let's just first read further down. They're saying the axis of symmetry of F. Now F is a parabola, and the axis of symmetry of a parabola is always x equals the x value of the actual turning point. So if the axis of symmetry is at negative 5, negative 8, or the turning point is at negative 5, negative 8, that means that the equation of the axis of symmetry is x equals negative 5. And we can see that they've put that straight line in there for us. All right. Now they're saying that this axis of symmetry intersects the x-axis at E. All right, so the x-intercept of this axis of symmetry is at E. Now, guys, if this line is x equals negative 5, that means that every single point on this line has an x value of negative 5. Every single point, including E and including D. So E is actually going to be the point negative 5, 0, because it intersects the x-axis, right? So it is the axis of symmetry is the x value of the turning point. Yes, exactly, it is. All right, so the x-intercept of the axis of symmetry also has an x value of negative 5, but because it's on the x-axis, it will have a y value of 0. Okay, then for D, they're saying that it intersects the line G, which is the line that they gave us the equation of, at point D, which has coordinates M and N. But guys, like I just said, D is also lying on this line. D is actually a point of intersection, right, of the axis of symmetry and the straight line. So we know that every single point on this line has an x value of -5, including this one. All right, so there we already know that M is -5. And if they're writing something in terms of M, they're probably going to ask us further down, what is the value of M? What is the value of N? All right, we've already identified that M is -5. Okay, then the last bit of information that they've given us here is that C is the y-intercept of F and G. So C, this point, we can see that it is the y-intercept of the parabola, which is F, and it is the y-intercept of the straight line, which is G. It's actually a point of intersection of both of them, but it is the y-intercept. And guys, remember when we looked at the equation of the straight line, we said that the y-intercept of this straight line, the C value, is 0, 9/2, which is 4.5, right? So there we actually already know that point C is the point 0 and 9/2, 4.5. Okay, so there we filled in quite a lot of information, and that is quite useful because now if they're asking us for things here, we already have it on the picture. And every time we calculate something else, we're going to fill that in on the picture as well. Now we see 4.2.1, lovely, write down the coordinates of A. We already found those. All right, the coordinates of A, the turning point, are -5 and -8. Okay, so 4.2.1. There we go, 2 marks. Guys, if the comments are in the way, then please just swipe to the left, to the right, and then the comments will disappear. Okay, but maybe I must just move my book a little bit like that. Okay, that's a bit better. All right, so there we have the coordinates of A. Next up, 4.2.2, write down the range of F. Now guys, range is all the Y values. Domain is all the X values. Okay, so if we're looking at this graph, F, remember, is the parabola. They want us to write down the range. If you just write the answer, will we still get full marks even though we worked it out prior? Well, you didn't actually work it out. We just read it off of the equation. Okay, so for that turning point, for those coordinates, you didn't actually have to show any working because it was just reading it off of an equation. So if you worked it out on this page and they're actually asking for they're asking for the values and you've done an actual calculation on your question paper, then you do have to write that calculation down because they're not going to look at your question paper in paper 1. So you have to make sure that whichever calculations you've made, you do write that on your answer script. Okay, the range of F. So now for the range of F, we're going to look at all the Y values. Now guys, the lowest Y value, the smallest Y value that this graph can have is -8. All right, that is the turning point. That graph is never going to, kind of go back down. It's never going to curl and go further down from -8. So -8 is the lowest Y value that this graph can possibly have. And then after that, once it's at -8, now it's going up, 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 forever and ever, basically, until infinity. All right? So that means that Y, all the Y values are going to be bigger than 8, -8, sorry, greater than -8, but also equal to -8, because at that point, right, the graph is actually equal to -8. So for 4.2.2, the answer is Y is greater than or equal to -8. Okay, and then from there, excuse me, you do have to just say that that is just for all real numbers. Okay, Y is an element of real numbers. That's just a little notation thing. You might not lose a mark if you don't write that, but you might. So just make sure that whenever you're answering something in inequality notation, that you do write whatever the variable was is an element of real numbers. Okay, 4.2.3. Let me just check. That was 1 mark. All right, so it would just be 1 mark for that answer. Next up, 4.2.3. Calculate the values of M and N. There we go. Right, I said they're probably going to ask us to find the values of M and N. Now, just to recap, Point D is this point with M and N as its coordinates, and this point lies on the axis of symmetry that they've given us, which is x equals -5, which is how we know that the M value is -5, because every point on this line has an x value of -5. But this point also lies on the straight line G, and we also have the equation for that straight line. The equation is y equals 1/2 x plus 9/2. So guys, if we want to know the y value of this point, right, which is what n is the y value of this point, we're going to have to take the x value that we have, which is -5. We're going to have to substitute it into this equation for x, and then that will allow us to solve for y. All right, so we said that because this point lies on the line x equals -5 and m is -5, that means sub in x equals -5 to get the value of this point. But now we need to be very certain of what we're going to sub it into. This point lies on the axis of symmetry, but it also lies on the line y equals 1/2 x plus 9/2. I hope so. I don't know. It still says lost connection, but I'm just going to keep going and hope for the best. All right, so let's focus. Let's get back to this. So calculate the values of m and n. Like I said, m is -5 because it is the x value of d, and it lies on the line x equals -5. N is the y value, so we're going to sub x equals -5 into the equation of the straight line, and that will give us the y value of the point, 4.2.3. All right, so I'm going to write here so 9, but I'm going to say 1/2 times -5 plus 9/2. All right, so the equation of that straight line was 1/2 x plus 9/2. I'm making it 1/2 times -5 plus 9/2. All right, then you can work that out in your head if you want. You can type it into the calculator. The answer there is 2. All right, so that means that m is -5 and n is equal to 2. It was a 3-mark question, this, so you would get 1 mark for m, then you would get 1 mark for subbing the x value, your m value, essentially, into the correct equation, and then a mark for n equals 2. All right. Cool, now 4.2.4. This is the type of question that it always comes up somewhere, either in paper 1 or in paper 2. Now, it's interesting that it's in paper 1 this time, because finding the area of a shape, that is traditionally a paper 2 kind of concept, right? It's more a geometry kind of thing, finding the area of OCDE. And that's what they're asking. But this is a paper 1. And guys, you do actually have to be aware that that could happen. They could sneak 1 or 2 almost like paper 2 type questions into a paper 1 exam. I remember, I think it was in 2018, there was big disappointment and unhappiness because they slipped a similarity question into a paper 1 thing, which was I think it was the calculus application question. So yeah, they're asking us here to find the area of this shape. So there we go. I'm just lining it up like that so you can see. OCDE. Now guys, this is a trapezium, so if you know the formula for the area of a trapezium and you have all the correct values, then you could use that formula. At our school, we don't actually even teach those formulas. We just teach our students to break the shape up into shapes that we actually know the formulas for. So if I draw a dotted line like this, now I'm not using a ruler, so it might be a bit skew, so I apologize. If I draw a dotted line like that, then I can see that I actually have a rectangle and a right angle triangle. All right, and we all should know how to find the area of a rectangle and how to find the area of a right angle triangle. I'm also just going to scratch out that -5. I'm going to put that there. All right, we know that those, now I wrote n again. We know that those are the coordinates of point D. All right, because that is now actually going to help us. No, this isn't Maths Lit, this is Maths. All right, so now to find the area of this whole shape, right, we need to know that if this is a rectangle, we know that the area of a rectangle is length times breadth. So now we need to figure out how long is this side actually. Now guys, if it's going from 0 to -5, then this is 5 units. Right, the length of that side is actually 5. And now we need to figure out what is the length of the breadth here. All right, how long is that side or those two sides? Now we can see it nicely if we're looking at this side of it, because this is where y is 0 and that point at D is where y is equal to 2. So this length is actually 2 units. Alright, so we can get the area of this rectangle by saying 5 times 2. Perfect, that's easy to do. Now let's quickly look at this triangle. It is a right angle triangle. We know that the area of a right angle triangle is half base. Now guys, this is the top side of the rectangle. So the base of this triangle is also 5 units. It's the same as that length, right? Times perpendicular height. Now to find the perpendicular height of this triangle, it's this part, eh? Now remember that from here to here was 2 units. But from point C to 0 is 9 over 2 units, because it's going from 0 to 9 over 2, and 9 over 2 is 4.5, all right? So this length is 4.5 units. Now, if I just want the perpendicular height of the triangle, I know the whole side of this whole shape is 4.5. The bottom length there is 2. So this perpendicular height of this triangle is going to be 4.5 minus 2. All right, so that length is actually going to be 2.5 units, 2.5 units. Okay, now I suggest that you write this all in one line. I know that some people, when they have to, or when they're calculating separate areas, they prefer doing them separately and then adding them together. But I always try and, I always suggest to do it in one line. It's less writing, it's less space for error. So let's try that. So area of OCDE is the area of the rectangle plus the area of the triangle. So I will write that. You don't have to if you don't want to. This is just for understanding this first line. So area of triangle plus, area rectangle plus area triangle. Okay, the area of the rectangle is then 5 times 2. That length times breadth that we calculated. Plus the area of the triangle is then a half times base, which was also 5, times perpendicular height, which was 2.5. You can write 2.5, you can write 5 over 2, it's up to you, doesn't matter. Okay, and then you can just type that into the calculator and get your answer, which I got as 65 over 4, or if you prefer, or if they say in the question perhaps that you have to round to 2 decimals, then that is 16,25. And just remember, when we're finding area, we have to write units squared. Okay, let me just check here. If I switch the Wi-Fi off, finding area, we have to write units squared. Okay, let me just check here. If I switch the Wi-Fi off, are you guys still hearing me? Did I lose you again? Can someone send me a yes? Why is it 2.5? Okay, I'll show you now again. So the 2.5, thank you. The 2.5 is referring to this part, the part that I'm shading in blue there, because that is the perpendicular height of the triangle. So when we do the rectangle and the triangle separately, we do have to get that. Now, if we're looking at OC, right, because the whole length of this whole shape is from 0 to C, or from O to C, and C is at 9 over 2. C is at 9 over 2, which is 4.5. But then we calculated that this length is 2 because it's from 0 to 2, which is the y value of D. So if this is 4.5 and that is 2, then that is 2.5. Okay, so that is where the 2.5 comes from. So this 2.5 was actually the 9 over 2 minus 2. Okay, cool. This was also a 3-mark question. So they would have given you 1 mark for that, 1 mark for that calculation, and then 1 mark for the answer. It's DBE, but they ask the same, it's the same type of content that you would have to study for IEB. So you can stick around if you are either. Optimization, I'm going to see if I get to that question. All right. If not, then I'll make a YouTube video on it. Okay, now we're getting to the inverse. Someone was asking about inverses. Determine the equation of g to the -1, and we know that this notation is referring to the inverse of g. So we're determining the equation of the inverse of g in the form y equals. Okay, so now whenever they're asking you to find the equation of an inverse, I suggest that you write the equation of the original graph first. So 4.2.5. And don't write it in function notation. So don't write it with g of x. So I'm just going to do g of x like this with a colon. And then I'm going to say, thanks for being here. Then I'm going to say, remember the equation of g that actually gave us this was y equals a half x plus 9/2. Now, when you are asked to find the equation of the inverse, what you're going to do is you're going to take the same equation, but you're going to swap the position of x and y. So when we're doing the inverse, we're going to say that this is now not y equals, but now x equals, yes, swap x and y, exactly, a half y plus 9/2. Guys, just for doing that, you already get your first mark. So if you just remember that to find the inverse, you need to swap x and y, then you already have 1 mark in the bag. Okay, now from here, you do have to always make y the subject. They also stated that in the question, but guys, even if they didn't, you would have to know that you have to write it in that form. Okay, because any kind of graph equation is only in the correct form if it's written as y equals everything else. So we're going to have to move this 9/2 over to the other side, and then we're going to have to divide by a half. Now before we do that, what I'm going to do is I'm just going to swap the two sides around. I prefer, it's a personal thing that I like whatever I'm solving for to be on the left-hand side. You don't have to do that, but I just think it's nice if the y is here because we want to end up with y equals everything else. Okay, so now the first thing that I'm going to move is this 9/2. So in order to cancel out the plus 9/2, I have to minus 9/2 from both sides. So I end up doing that. All right, so this plus 9/2 essentially moved to the other side. And now we have to divide by a half. All right, so when you are dividing by a half, shouldn't the y be negative? So I didn't move it, I just swapped the two sides around. Okay, so that's why I didn't make the y negative. If you moved only the half y and you left the 9/2 there, then yes, the y would become negative. Okay, but I literally took that, both of those terms, put them there, and I put the x on the other side. Okay, Kyle, this is confusing. I'm sorry to hear that. If you can tell me what's confusing, then I could help you, or I could explain a bit more. Alright, so here now we need to divide by a half. Now guys, it's a bit difficult to do that if you just write it like this, right? Because if you want to write x minus 9/2 over a half, that's not good. Okay, we're actually not allowed to leave a fraction like that. We can't have a half as our denominator. So what we need to think of is, remember, when you are dividing by a half, that is actually the same as if we were to tip and times. Because when you're dividing by a fraction, remember you tip and times rather, right? So times, when you tip 1/2, that becomes 2/1. Okay, so now I actually have, let's write this in a different way, just a way that seems more familiar. Times 2/1. 2/1 is just 2, all right? 2/1 is just 2. So now, instead of putting a times 2 at the back of the bracket, let's put it in front, because that's what we're used to, right? We don't usually have a bracket and then the 2 behind the bracket. We normally write it like this. Okay, so I'm not actually doing any calculations. I'm just writing it slightly differently so that it's more familiar. This is more, this looks more like what we are used to working with. Okay, and now you just need to multiply that 2 in. Okay, so you're going to say y is equal to 2 times x is 2x. And 2 times negative 9/2. See what happens when you do that. The 2's are going to cancel each other out. Alright, so it's actually going to just become negative 9. Now guys, if you can do this manipulation in less steps, that's perfectly fine. You don't have to show every single step like I did now. I just am doing it for, for understanding. Okay. Alright. Now that was only a 2-mark question, so it's literally 1 mark for that and 1 mark for getting to this line. Okay, so they are a bit stingy. Yes, I am on YouTube. Yeah, if you just go to my profile, you can click on the Instagram icon, and then you can, school is over, stop working. You don't have to be here, sir. Princess, no, you'll be fine. Don't worry. It's good that you're here and that you're learning. Okay, this is functions, yes. Okay, let's see. Now, 4.2.6 is the problem-solving question of this question. All right? Yeah, I'm going to try get to cubic functions. So 4.2.6, and it usually is like that, guys. In your final exam, they're not going to give you one super hard question. What they do is they take the problem-solving section or the problem-solving marks that they can use, and they split them up in between the different questions. So you can expect that in your final exam questions, the first few questions are usually quite straightforward. Like if we're looking at this, write down the coordinates of the turning point. That was quite straightforward. Write down the range of f. That was all right to do. The values of m and n, that wasn't too hard. But then at the end, usually the last question of each question is slightly harder. All right, so we're going to go through this one now, but I don't want you to panic if it doesn't make sense, because you can make up your marks in these first parts. All right, we're not going to do trig today. We are only going to do paper 1 stuff, just functions and some calculus. Okay, now 4.2.6. Now it's important that we read this question carefully. They're saying, if h, now remember that they didn't give us h. H is now a new function, all right? It's something completely new. If h is the inverse of g, which we found here, right, plus k, all right? So graph h, they're now telling us what graph h is. Graph h is, I'm going to write it here on the page. Remember, we just found the equation of the inverse. It was 2x plus 9 plus k. Now, guys, we don't know what k is. I'll look at it now again quickly. Okay, we don't know what k is. K is just a constant. Sure, there's a lot going on here. Sorry, guys, car alarm going off, dog barking. Just hang in there. K is a constant, all right? It's some kind of number. It doesn't really matter. It doesn't matter what k is. Guys, I'm going to post this recording to my YouTube channel later. So if you miss anything or if your connection kicks you out, then don't stress. I will be posting it, and I'll post it afterwards, okay? 2x minus 9. Oh, yes, it was. Thank you. Thanks so much for reminding me. It was 2x minus 9. Thank you very much. All right, so that was the inverse. Okay, so h was the inverse of g, which was 2x minus 9, plus k. Like I said, k is just a constant. It just represents a number. Okay, if they're giving us something like that, then it might not even mean anything. So let's not panic when we see the mention of k. All right. Determine the coordinates of the point of contact between h and f. All right, so they're saying if h is a tangent to f, so this line, because this will give us a straight line as well. If this line is a tangent to f, determine the coordinates of the point of contact between this line and the parabola. All right, so let's look at the parabola. Guys, it's important that we also remember, what is a tangent actually? How would we get the equation of a tangent? Let's write some stuff down here. I'm just going to tear this page. It's a bit difficult to do it with one hand. Ooh. Okay, now let me just flip it over. Okay, there we go. All right, so let's just quickly recap. What is a tangent actually? A tangent to a curve. How would we find the equation of a tangent to a curve? Because that is important. We're going to have to use that knowledge for this. All right, so tangent to a curve is always of the form y equals mx plus c. Yes, correct. We're going to use derivatives. All right, so tangent to a curve is y equals mx plus c. Now, m, the gradient, is always the derivative of the curve. Yes, using calculus, exactly. And that's another thing, guys. Sometimes they just like sprinkle some calculus into other questions. The calculus is not always confined just to a specific question, because here this is a functions question and we need to use calculus. All right, so to find the gradient, we would find the derivative of the curve. And then once we have that derivative, because the derivative is going to have an x in it, right? But to find the gradient, it needs to be a number. So once we find the derivative, then we sub in the point of contact, and we actually sub in the x value of the point of contact to get the value of m. Okay, so tangent to a curve, to get the gradient, we would find the derivative of the curve and then sub in the point of contact. But guys, let me just write this question, the number here, 4.2.6. We said that h, they're telling us that h, right, is the tangent to this curve, h of x. And we said that h of x is 2x minus 9 plus k. Now, like I said, k is just another number. So the minus 9 plus k doesn't actually have anything to do with the derivative, right? The derivative of the curve is 2. Okay, we have that there. Because we know they've told us that h is the tangent to this curve, meaning that 2x, and that will be our c value. 2 is actually the derivative of the curve. 2 is the gradient. All right, so I'm going to write that there. M of tangent is equal to 2. Therefore, what is the gradient of the tangent? How do we get it? Therefore, the derivative of the curve must be equal to 2. Okay, that's how we're actually going to figure this out, guys. We know that the gradient of the tangent is 2. They told us that h is the tangent and the gradient of h is 2. So we know that the gradient of the tangent is 2. But we know that to find the gradient of the tangent, we would usually find the derivative of the curve and then sub in the point of contact. All right, so let's find the derivative of the curve. We haven't actually done that yet. Remember that the curve was f. That was the equation. Now, in order to find the derivative of this, we're first going to have to multiply this bracket out. Okay, you don't know. In core maths, there isn't a way of finding the derivative of this without actually multiplying it out first. So I'm just going to write that curve equation down, and then we will just multiply it out. So it was a half x plus 5 squared minus 8. Okay, now I'm going to write it like this. There is a shortcut for squaring a bracket. If you know that shortcut, you are more than welcome to do it. But if you don't know the shortcut, then it's better to just, but chain rule is not in core maths. Chain rule is only taught in AP. So if you do AP, then you are welcome to use chain rule, but it's not in the core maths syllabus. All right, a half. Now I'm just going to FOIL these brackets out. X times x is x squared. X times plus 5 is plus 5x. 5 times x is again 5x. And 5 times 5 is 25. Minus 8. Okay, now I'm going to multiply my half in. Let's just quickly check here that this is 5x plus 5x. Are we all fine with me just as a little step here, just saying that that will be plus 10x? All right, so if I were to simplify those terms, that would be, just dropped my pages, but that would be 10x. All right, so we have a half x squared plus 10x plus 25 minus 8. Now I'm just going to multiply that half in. So a half x squared plus 5x. Then if I multiply half by 25, that gives me 25 over 2. And then I have my minus 8. Okay, that's fine that you know about chain rule. You can use it if you want to. They will mark it correct. Let me just grab my paper here because everything fell on the floor. I'm just having a wonderful day. Technical difficulties, paper on the floor. Okay, let's see. Where was I? All right, so we are on 4.2.6. All right, so let's just actually simplify that as well, because 25 over 2 and minus 8 are both constants. So I can get that. Oh, I see here that I didn't do it properly when I worked through it myself beforehand. All right, 25 over 2, that's 12 and a half, right? And if you minus 8 from that, that will give you 4 and a half. Is that correct? 4 and a half, which is 9 over 2. Let me just double check that. 12, this is 12,5, yes, minus 8, yes, is 4,5. Okay. My name is Miss Hanekom. Okay, so let's see. Now, what we wrote here at the top, this is the key to getting this answer. I put 5x instead of 10x. Yes, because I multiplied a half into this bracket, right? That's where that 5x came from. Because a half times x squared is a half x, and then a half times 10x is 5x. Okay, so that's where that 5x came from there. Now, guys, we said that the gradient of the tangent is 2, meaning that the derivative of the curve, the derivative of this, is equal to 2 as well. So we have the curve now, and we can find the derivative of this, right? So let's say, therefore, f dash x, the derivative of f, is, so now we can quickly go over that derivative rule. If you have your separate terms, you have the exponent of x. You're going to basically multiply whatever is in front of this variable, so a half, you're going to multiply it by the exponent. So a half times 2 is just 1, which we don't have to write. Then you're going to put x, and then you're going to minus 1 from the exponent. So 2 minus 1 is just 1. So we're left with x there. Plus, if you have 5x, the exponent of x is 1, right? So you're going to say 5 times 1, which is 5. And then x to the power of, when you minus 1 from 1, you get 0. So this is going to give you x to the 0. So that is actually just 5. All right, so the derivative of f is x plus 5. But what did we say? The derivative has to be 2. So this is going to be equal to 2. Right? Now this is such an easy equation to solve. We're just going to move that plus 5 to the other side. We're going to say 2 minus 5, and that will give us x equals negative 3. Now, what is this now actually? This x value is the x value of the point of contact. All right, so when you take the value of the gradient and you make it equal to the derivative and you solve for x, that is the x value of the point of contact of your curve, of your parabola, and the tangent. All right, so the x value, and that's what they asked us for, right? They asked for the coordinates of the point of contact. So the x value of your point of contact is negative 3. Now, how can we find the y value of the point of contact? Very simple. We're just going to substitute it into the equation of the graph that it lies on. Now, do I have that page? Let me just grab it. It fell and it moved all the way across the floor. Okay. The equation of the curve is a half x plus 5 squared minus 8, right? All right, so if we know the x value of the point of contact, we're going to substitute it into this graph, into this equation, and that will then give us the y value of the point of contact. Okay, so if x is negative 3, then y will be equal to, you can actually substitute it in here as well, because this is also the equation of the graph, but it's up to you. A half times negative 3 squared plus 5 times negative 3 plus 9 over 2, or you can substitute it into the original equation, which is what they gave us, and you will get the answer negative 6. Meaning that your point of contact, and this is what they were actually asking us for, is the point -3, -6. This is a great idea. What was that idea? Yes. Katie, I think there is a network problem and I'm not sure how to fix it. I've tried resetting the router, all sorts of things. Let me try again to go onto the Wi-Fi. It's very frustrating. I'm really sorry about that, guys. I don't know why the Wi-Fi is acting up, but I will definitely post this on on YouTube afterwards if you're missing out on anything. Okay, let's go on to the next question. That was question 4. That was the first functions question. Let's look at question 5. Okay. You're welcome, Sibusi Siwe. All right. Let's see. Question 5. The graph of f of x equals 3 to the negative x is sketched below. Now, if our exponent is, if the x is in the exponent, if x is in the exponent, then we know that it's an exponential graph, right? Which we can see also it is an exponential graph. A is the y-intercept of f, all right? A is the y-intercept of f, and then, and the line y, and B is the point of intersection of f and the line y equals 9, all right? B is the point of intersection, there we go, of f and the line y equals 9. So guys, this is similar to the previous question where we had that axis of symmetry that was x equals -5. Now they've given us the line y equals 9. And this is meaning that every single point on this line has a y value of 9. So point B, for example, has some kind of x value. We don't know what that is yet, all right? We might have to figure it out eventually. But the y value of this point is definitely 9. Okay. Now, let's see. What are they asking us for? They're saying write down the coordinates of A. Now, guys, they have given us the equation, right? So let's actually write that down. Question 5. So for question 5, f of x is 3 to the negative x. Now, guys, some people don't like working with negative exponents. So if you want to, you can rewrite this as a third to the power of x. All right, you do need to know that 3 to the negative x is the same as a third to the power of x. All right, but you can work with it in that form as well, unless they say specifically in the question that your exponents must be positive. Then you would have to write it like that. Okay, let's see. Where am I? Write down the coordinates of A. Now, A is the y-intercept of this graph. And how do you find the y-intercept of any graph? You make x equal to 0. Working with negative exponents is better. Yeah, it's up to you. You can decide whether you want to leave it like that or you want to write it in that form. Okay, so to find the y-intercept of any graph, it doesn't matter which type of graph it is, even a trig graph, you're going to have to make x equal to 0. All right, so yes, it is 0, 1. So y is going to be 3 to the negative 0, which, I mean, negative 0 isn't really a thing. All right, that's just 0. And that will then give you a y value of 1. Or if you worked with this form, you would say y is a third to the power of 0. And we all know that anything to the power of 0 is 1. Okay, so A is the point 0, 1. Let me just see, there was a question. Ma'am, can I rewrite it as a third to the power of x? Yes, you can. All right, so that's what I did over there. So I was saying you can use it in that form or in that form. It's up to you. Okay, that's an easy mark there. 0, 1. Next question. Determine the coordinates of B. There we go. They're asking us for the coordinates of B. We already know that the y value of B is 9 because it lies on the line y equals 9. All right. So then we need to find the x value. Now guys, to find the x value, if you have the y value, you're going to go to the equation and you're going to write it. You're going to sub in 9 for your y value and then solve for x. Now in this case, it's actually easier to work with the 3 to the negative x, right? So I'll show you quickly. 5.2. If you have your equation, I'm just going to write it again. It was y equals 3 to the negative x. Now for point B, we know that our y value is 9. So you're going to say 9 is equal to 3 to the negative x. Now guys, if you have an exponential equation like this, all right, you could use logs if you wanted to, but this is an easy one to solve. So let's try and solve it in the easy way, which is quicker, if we can. Can you write 9 as 3 to the power of something? 3 to the power of what will give you 9? Can someone send me an answer? I like when you guys interact with me. So I'm trying to write 9 with the same base. I want to write 9 as 3 to the power of something. 3 squared, thank you. Right, so 3 squared is equal to 3 to the negative x. Okay, good, power of 2. So now we have the same bases. So in order for our exponents, in order for 3 to the power of 2 to be equal to 3 to the negative x, we are going to have to say that negative x must be equal to 2. I'm sure you guys know this, all right? You've probably been doing this since grade 8. So therefore, x is negative 2. All right, so point B, yeah, you drop the bases. So therefore, B is the point negative 2 and 9. Okay, let's see. That was a 3-mark question. So it would have been 1 mark subbing in 9 for y, and then 1 mark for each of your coordinates. Okay, so that's quite nice, giving 3 marks for that question. Okay, next up, 5.3. We just move this down again. 5.3. Stats or Euclidean, I'm going to do that after you've written paper 1. Okay, so I will do paper 2 live, but we're just focusing on paper 1 for now. All right, so now we said that this x value is 2. Okay, negative 2, I mean. So that's negative 2. That is the point 0, 1. Okay, let's take a look. Write down the domain of f to the negative 1. So they're asking us for the domain of the inverse of f. But do we have the inverse of f? We don't have that graph, hey? They've only given us the graph of f. Now, if they've given us the graph of f and they're asking for the domain of the inverse of f, you need to remember that the domain of the inverse will be the same, in a way, as the range of the original. Okay, so I'm going to write that down. 5.3, domain of inverse is the same as the range of the original. But remember that the domain, when I'm answering that, I need to write x, and when I would normally answer the range, I would write y. Okay. So the domain is just all the x values that can be covered by the graph. All right, but in this case, they didn't give us the inverse. They didn't give us the graph of the inverse, so we have to use the graph of the original. So guys, if we're looking at this graph, can we figure out what the range of this graph is? Right? If we're looking at this graph, the range, or the y values of the graph, right, we can see that this graph won't go past 0. Okay? Yes, it is x. Okay, but we're looking at the y's of the original so that we can write the x's of the inverse. Okay, so y greater than 0. Perfect. All right, so that is the range of the original. So now I'm just going to write that here. The range of f is y greater than 0, meaning that the domain of the inverse will be x greater than 0. Okay, so therefore x greater than 0. And like I said before, whenever we're writing an answer in inequality notation, let's just add x element of real numbers just in case, all right? But you look at the range of the original to get the domain of the inverse. How is it y greater than 0? Because this is an asymptote, right? That is the asymptote, the x-axis, and the x-axis is y equals 0. Now the graph is not going to touch that x-axis, it's not going to touch that line. Okay, it almost kind of looks like it does on this graph, but it's not supposed to, all right? So it will be all values bigger than 0. Okay, now 5.4, this is an interesting question. They're saying, describe the translation from f to h, and now they're giving us the equation of h. All right, so I'm going to write that down. Okay, h is 27 over 3 to the power of x. They're saying, describe the translation from our original graph. Now remember, f of x was this, right? F of x was 3 to the negative x, or we could have written it as a third to the power of x. Now guys, what is a translation again? A translation is when you are moving something, right? Translation is just a shift. So moving up or down, moving from the left or the right. To make the comments disappear, you just need to swipe right on your screen. And then the comments should go away. Oh, my apologies. Okay, so we are going to have to rewrite this equation somehow so that we can see how did this equation become that equation? What actually happened? How did the graph move in order for it to turn into this equation? Now, guys, I hope that you all agree that 27 is the same as 3 cubed, right? So I'm just writing them both with a base of 3 so that we can simplify it a bit, because we need a 3 or we need a third. Okay, we need that as our base in order to figure out how has this graph moved. Now we need to think back to grade 8, grade 9 exponent laws. When you are dividing and you have the same bases, you're going to minus the exponents, right? So you're going to say 3 minus x. Okay, now, yeah, I'm fine. I'm just a bit sick. Now, remember, we want to get it to look like this. Okay, it's similar. It's similar. Let's look at that. 3 to the negative x plus 3. What did I do? I've literally just swapped the two terms around. Okay. Just swap the two terms around. Now, from here, it's actually easier to write it as a third, because look at what I'm going to do. I'll just write it down and then you guys can tell me if you agree with what I'm doing or if you understand what I did. Right? So what I always teach my kids is that this is the standard form of an exponential graph. Y equals a times b to the x minus p plus q. All right? And this p value, sorry, there are people having a nice chat outside my window here. Whatever your p value is, that is the amount of units that your graph has shifted. And whatever q is, obviously that is whether it's shifted up or down. All right, we can see that we don't have a q in either one of these graphs, so that's fine. The graph hasn't shifted up or down. Okay, but now we need to figure out what happened from this equation to turn it into this equation. How did the graph move? How did the graph of a third to the power of x move to become a third to the power of x minus 3? Right? Now, guys, if you have an x minus 3, that means that you've moved 3 units to the right. Yes, exactly, 3 to the right. Okay, it's just like when we spoke about the parabola, where you had an x minus p in the bracket. If it was an x minus 3, you've moved 3 to the right. It's the exact same thing with an exponential graph. Okay, good. You guys are giving the correct answer. Yes. So from this graph to this equation, right, the graph has shifted 3 units to the right. So that's the thing. If you leave it like this, it does look like it shifted 3 units to the left, right? But actually the whole shift, it shifted from negative x to negative x minus 3. Okay? All right, I'll explain that again. So are you guys fine with writing 27 as 3 cubed? And then changing that to 3 to the 3 minus x. Right? Now I'm trying to see what happened to my original graph to get to the new graph. Okay, so now I just, from this step to this step, I haven't changed anything. I just put the negative x in first, in the front, and then I did my positive 3 there. Okay, so I've literally just swapped the two terms around. But now, from here, from negative x, it shifted to negative x minus 3. So you do have to take that negative out. Okay, so it is difficult. This is a tough one, which is why I said it's actually easier if you're looking at a third to the power of x versus a third to the power of x minus 3. It's easier to see from there. Okay, so we've shifted 3 units to the right. 5.5. Now this is another tough one, all right? And there are multiple ways in which you could do the last one. And the last one is a bit of a problem-solving question. You might have seen similar ones in the past. So now they're saying, remember h is this graph. Determine the values of x for which h is smaller than 1. Now, if you go and you actually find this paper, you can find it online, you can find it on the app that I use. I've posted about it before. You can look at the various ways in which they've done it. But I think the easiest way to answer this question is to actually just draw the graph in. All right, draw the graph of hx. Remember that we just said that h of x is actually a third to the x minus 3. It's this exact graph that has shifted 3 units to the right. So this point 0, 1 is now actually going to turn into the point 3, 1. Right? Remember when a graph shifts 3 units to the right, every single point on that graph shifts 3 units to the right. Okay? So the point 0, 1 is going to become the point 3, 1. I'm just quickly going to try and draw this graph in. You don't have to draw it perfectly, all right? And I'm also doing this one-handed, okay? So I'm just trying to just do a little, that's not a great drawing, but hopefully it works. Okay, I should have actually made it go a bit further down, but anyway. Now, let's see, yes, you could do that. There are just some issues with this inequality because we have a negative x or a third. All right, you can do that. So I'm just showing you how to solve this using the graph. It has the least amount of steps. But if you want to use the inequality, perfect, that's fine. All right, I hope it makes sense that if the graph of f shifts 3 units to the right, then that means that the point that was 0, 1 becomes the point 3, 1. Okay, so this is now h. Not a good drawing of h, but good enough, I think. Now they're asking, where is h smaller than 1? Now, guys, you have to remember that h of x means y. So they're asking, on the graph of h, where are the y values smaller than 1? Now, if we're looking at this point, right? This point has a y value of 1. It's paper 1 of last year. This point has a y value of 1. On the left-hand side of this point, right? All my y values will be bigger than 1. Do you guys notice that? Because it's increasing on this side, all right? It's going up. So on the left-hand side of this point, y will be greater than 1. On the right-hand side of this point, y will be smaller than 1. Okay, like I said, I didn't draw it very well, but it's supposed to go down. All right, and then it's going to go closer and closer and closer to the x-axis. So where is y smaller than 1? On the graph of h, on the right-hand side of this point. And which x values lie on the right-hand side of 3? All x values that are bigger than 3, right? For example, 4, 5, 6, 7, 8, 9, 10. So the answer to this question, they're asking, determine the values of x for which y is smaller than 1. And we just said now, it's all of the values, all of the points to the right of 3. So where x is greater than 3. Okay. Now guys, there usually is a question like that in each paper, so you can go look back at some other past papers and then you can see what happened. You can practice some more, I'm trying to say. All right, so I'm just going to say here 0, 1 shifted to 3, 1. Therefore, where x is greater than 3. Okay, done with question 5. I just quickly want to take a look here. It's already 4:15. I'm not going to do question 7 now. All right, question 7, you can look back at loads of past papers. There are always questions like this. They always ask a first principles question. They always ask these types of questions. What I do want us to get to is the cubic function or the cubic graph question, because a lot of people have been asking for help with cubic graphs. So let's look at this question. All right. Yes, here we go. Cubic graphs. These are, no, this is the national paper that they wrote last year. Okay, so they're saying, question 8, the graph of G, which is ax cubed plus bx plus c. Now guys, remember that the graph of Q is usually, or a cubic graph is usually of this form. There's usually a plus d as well. Now, if they're telling us that there's no d value, then that means that the y-intercept is 0. Okay, we can see that though. But just in case they didn't give us a graph or they didn't give us that information, remember the d value in a cubic graph equation is always your y-intercept. Okay, they're saying a cubic function having a y-intercept of 0 is drawn below. The x-coordinates of the turning points of G are -1 and +2. All right, so they've given us the x values of these turning points. They haven't given us the y values, but that's all right. Okay, so this is the x value of the one turning point. That's the x value of the other turning point. 8.1, for which values of x will G increase? All right, so now for that, guys, we just look at the graph. The increasing part of this graph, if we're looking at this part, the y values are getting smaller and smaller, so this part is decreasing. If we're looking at this part in between the two turning points, this part is increasing, right? Because the y values are getting bigger. That's what it means when they're saying increasing. It means that your y values are increasing. Your y values, they're negative over here, there the y value is 0, and then they're getting even bigger. All right, and then after that turning point, it's decreasing again. So this is where the graph is increasing. They're asking for which values of x will G increase. So between -1 and +2. Okay, that is the first answer. So 8.1. So where x is between -1 and +2. And that's 2 marks. So you'll get 1 mark for each. Okay. Let's look at the next question. Now this is an interesting question and it is also 2 marks. Write down the x-coordinate of the point of inflection of G. Write down the x-coordinate of the point of inflection of G. Now guys, on a graph like this, you usually can't read off that value. You need to do some kind of calculation. Now remember, for point of inflection, that is where a graph changes its concavity. Yes, this will be on my YouTube. All right, so this is where the graph changes concavity. So it changes from being concave up, which is like a cup, right? So like that section would be concave up, for example, all right? To being concave down, which is basically like a downwards facing parabola almost, that same kind of shape. So somewhere here we will have our point of inflection, all right? Where the graph changes from being concave up to being concave down, all right? Now guys, usually to get the point of inflection, we would take the second derivative. Oh, this is actually G, so let's just write G instead of F. I'm so used to using F. So we would take the second derivative of whatever the function is, and we would make that equal to 0. We would find the second derivative, and then we would solve for x, and that would give us the point of inflection. In this case, we don't have the equation, all right? And we also don't actually have enough values, enough information at this point to find the equation. All right, now what you need to remember in this case, if you don't have enough information to get the equation, you're going to find the value that is halfway between your two turning points. All right, so I'm just going to write here, this is at the x value, halfway between turning points. Okay, and that's actually perfect because we have our two turning points. We know the x values of the two turning points, so we can easily find the x value that lies directly halfway between those two. All right, now you can do this in your head if you want. You can look from -1 to 2, that would be 3 units, right? From -1 to +2, that's 3 units. So halfway between 3 would be 1.5. So if you're going from -1 and you're going 1.5 units, then that will get you at x equals 1/2. Or you can do a calculation if you want. All right, maybe the values are difficult to work with, or you don't want to risk just doing it in your head. So you can say there that x is going to be equal to, remember, whenever you're finding a value that's halfway between two values, 2 points, whatever, then you can always add the two values together and divide by 2. All right, you're essentially finding the average of those two values. So if you do that, -1 plus 2, that's +1, divided by 2 is 1/2. Yes, exactly. -1 plus 2, and then you divide that by 2. Good. So this is actually the x value of the point of inflection. Okay, so if you don't have the equation, you can't find your second derivative, you're going to take the x values of the two turning points, add those together, and divide by 2. Okay, that was also a 2-mark question. I suppose they would give you a mark for the working and a mark for the answer, but if you just wrote the answer, you would also get 2 marks. Okay, 8.3. For which values of x will g be concave down? Now, guys, we know now, and I'm just going to kind of eyeball it, all right? Let's say that that is the point of inflection, all right? At that point, we don't know what the y value is. X is equal to 1/2. Now, guys, on the one side of the point of inflection, your graph is concave up. On the other side of the point of inflection, your graph is concave down. All right? So if we're looking at this, we need to look at the actual shape of the graph, right? A nice way of remembering how it looks when it's concave up is it looks like a cup. All right, so this part, concave up, looks like a cup. That part is concave up. The other part, the part that is facing down, essentially, right, like that part is concave down. So where are they asking? For which values of x will g be concave down? So it's on this side of x equals 1/2, right? It's not concave up or concave down at this point, right? It's almost like it's in between. And then after that point, it's concave down. So this will be where x is greater than 1/2. All of these x values here on this side, if we're looking at the x-axis, all of these x values are greater than 1/2. Okay, so 8.3, where x is greater than 1/2. All right, so essentially you read that off of the graph using your answer from 8.2. That was another 2-mark question, so I'm assuming you'll get a mark for saying greater than, and you'll have a mark for using the x value that you got in the previous question. Now, 8.4. This is a nice question. If the derivative of g is this, -6x squared plus 6x plus 12, determine the equation of g. All right, so they've now given us the equation of the derivative, and they're wanting us to find the equation of the original graph. Now, what you're going to do here, I'll write it here underneath. They've given us this equation, right? Sorry that it's going blurry all the time. All right, the derivative is -6x squared plus 6x plus 12. Hi, Miss Angler. Thanks for tuning in. All right, so the derivative is g dash x. That's -6x squared plus 6x plus 12. All right. Now, they're asking us to find the equation of g. Now, guys, the only thing that they told us actually was that g is this. ax cubed plus bx squared plus cx. Okay, that's all we know. Now, what we can do here, and this is quite a nice method, is we can actually find the derivative of this equation, right? Even though we have an a and a b and a c, we can just treat those as constants because they are, right? They're actually numbers, a, b, and c. So, the derivative of g over here, apologies about the dog barking, we know that this is some kind of number, all right? It doesn't actually matter what number it is now, because if we were to derive this term, we would multiply the exponent, which is 3, by whatever that number is in front, all right? So a times 3 would give you 3a, and then you would minus 1 from that exponent, right? So it would be 3ax squared, okay? Next term, again, b represents a number. Okay, so whatever b is, when we move that 2, when we multiply the 2 by that number, 2 times b is just 2b. And then x, the exponent is going to be 2 minus 1, which is 1. And when we have cx, remember that c is, again, a number. So whatever this exponent is, remember that's a 1. We're going to multiply it by c. So 1 times c is just c. And then we're going to end up with x to the 0, okay, which is just 1, so we don't have to write that. So now look at what we have. This is actually quite cool. We have that the derivative is both of these equations, all right? So the derivative, guys, if the comments are in the way, you can just swipe right, and then the comments will, you can just swipe right, and then the comments will disappear. Then you can see the whole screen, all right? What do we notice here? We have that the derivative is negative 6x squared, but the derivative is also 3ax squared. So that means that negative 6 should be equal to 3a, right? Because this is the same thing. This is the same derivative, just written in two different ways. So if negative 6x squared is 3ax squared, that means that 3a has to be equal to negative 6. In the same way, if 2bx is 6x, that means that 2b has to be 6. And look at that. Plus c, the constant term, has to be plus 12. So c is 12. Okay, so let's recap. How did we do that? I just wrote down the equation that they gave us for the derivative, and then I derived this standard form of the original. Just remembering that a, b, and c are numbers, so I treated them as if they're numbers. Okay, so now I'm going to say 3a must be equal to negative 6. So a is then negative 6 divided by 3, which is negative 2. Okay, then 2b has to be equal to 6. I see your question, I'll answer it just now. Okay, 2b is equal to 6, so then 6 divided by 2 will be 3. The last thing, c must be equal to 12. Okay, so is this Mario that was asking, what would you do if they didn't give you this form? Well, this is just the standard form of a cubic graph equation. So they didn't actually have to give you this. You have to know that a cubic graph equation is always ax cubed plus bx squared plus cx plus d. All right. Now, because of this graph having a y-intercept of 0, which we can see there, the d value is 0. Okay, so they didn't actually have to give you this equation at all. You would have to know. Okay, so ax cubed plus bx squared plus cx plus d, but d is just 0 because the y-intercept is 0. Okay, you can integrate, guys, if you did, or if you, yeah, because AP they've written already. If you did AP Maths, then you could integrate, that's fine, it will give you the right answer. It's just not in the core syllabus. All right, so this is how the question is set up to be answered. Okay, that is a 4-mark question. You would get a mark for doing this. So for deriving, getting the derivative of the original equation, then you would get a mark for your A and your B and your C values. Okay, 8.5. This is going to have to be the last question that we do today because my toddler is on her way from school now. What happened to D in the equation? D was 0 because the y-intercept of this graph is 0. And in D is, in the, it's because I'm reading questions at the same time as answering questions. Sorry, let me just focus. In this equation, D is always your y-intercept, so the y-intercept is 0, meaning that D is 0. Ma'am, for the previous question, x was divided by half. May I ask why? For the previous question, are you referring to... I'm not sure what the previous question is. Are you talking about this, 8.2? So this was when... Why was it divided by 2? Because we found the value that was directly halfway between the two turning points. So we add the two turning point values together and we divide by 2. So the value there was a half. Okay, guys, I'm not sure when I'm going to go live again. It depends on because I am a full-time teacher, so it depends on my extramural stuff next week. I know that you are writing on the 5th. If you are a DBE student, and you are writing on the 8th, if you are writing IEB. So I will do one more paper 1, live session before then. Just keep an eye on my profile. I post about it multiple times once I've decided when I go live. And then I also create an event. So the event banner will actually be on my profile. So if you miss the video, then you can see the actual, you can just check on my page every now and then. And then you can see there when the event will be. Okay, I promise I'll do that. All right, let's quickly do this last question because it is another problem-solving question, and quite a few of my kids from last year actually really struggled with this question because we had never discussed this this type of method. It had just never come up in class before. It was something completely new. So they're saying determine the equation of the tangent to G that has the maximum gradient. Write your answer in the form y equals mx plus c. So now, determine the equation of the tangent to G that has the maximum gradient. All right, so this is an interesting concept. And like I said, it's something that had never come up before in class. I actually had never even seen it in a textbook. At no point in my 8 years of teaching has it ever come up before. The idea that the tangent that has the maximum gradient is always at the point of inflection. So I'm going to write that down, and please make a note of this somewhere, because the other thing is once a question has been used as a problem-solving question in an exam, it's no longer seen as problem-solving going forward. So now that they've asked this question in the 2020 paper, they could expect you to know this in the 2021 paper. All right, so... yes, at the inflection point, exactly. So the equation of the tangent to G that has the maximum gradient. So actually, let me write it on the page. I'm just using so many pages here, but that's fine. Let me just move that down. Okay, so let's write a little note, guys. Like I said, they can now expect you to know this because it was tested in the previous exam. All right? The tangent to a curve with the maximum gradient is at the point, sorry that it goes so blurry all the time, is at the point of inflection. Okay, and I'll try to show you now on the graph. It's a bit difficult to see if the graph isn't like super zoomed in, but I'll try my best to show it to you. Okay, so I'll move this down again so that you can write it down again. So we're saying the tangent to a curve with the maximum gradient is at the point of inflection. Guys, if we're looking at this graph, right, I've just kind of guessed that that is where the point of inflection would be. So it's halfway between -1 and 2. Remember, a tangent is a line that touches a graph only at one point. Okay, so if you have your tangent here, which is almost impossible to imagine that there could be a line, but it could be like a super short line as well, hey? So if you have your tangent at the point of inflection, but then you have a tangent before that or after that, the tangent at the point of inflection is going to have the maximum gradient, the highest gradient value. All right, and that is quite interesting. It's just something that we had never really thought of before. I remember that all the teachers at my school, we were all like, whoa, we've never like even asked this type of question before. Oh, this dog. Sorry. It's the neighbor's dog. Okay, so they're asking, determine the equation of the tangent to G that has the maximum gradient. So we need to know that the tangent to a curve with the maximum gradient is at the point of inflection. And we don't know what this point is, but we do know that the point of inflection was at x equals a half. And that's actually all that we need, guys. Remember to find the equation of a tangent. We know that it is y equals mx plus c. Right? The gradient is the derivative of the graph. Okay? So the gradient is g dash. But that will give us a value that is in terms of x. That will give us a value that has x in it still. Oh my goodness, this dog. What is going on? Wow. That will give you something that is in terms of x, right? And guys, they've actually given us this derivative. We could find it because we actually know what the equation of the graph is now. But they gave us g of x, g dash of x. Remember, they said that this is negative 6x squared plus 6x plus 12. All right, so that is the gradient of the tangent. But this doesn't really, I mean, it helps us, but this isn't the actual gradient because the gradient is actually a number. It's supposed to be a number. To get this to be a number, we have to take the x value of the point of inflection and sub it in wherever we see x. So the gradient is going to be negative 6 times a half squared plus 6 times a half plus 12. Okay, we can calculate that. That will give us a value. I did work this out before. I can't remember what that is now. And I've lost my page. My things have fallen. Let me just quickly work it out. You can work it out in your head if you want to. I also probably could do that, but I'm just in a bit of a rush now. Plus 12. So that is 27 over 2. All right, that is the gradient of the tangent. Factorize. You're not going to factorize this because you are just, this is supposed to give you the gradient, all right? So you're not going to factorize it because we know what x is. We know that x is a half, so we're just going to substitute it into this, and then the gradient is 27 over 2. So that means that our equation is something like this, 27 over 2x plus c. Or, guys, there is a different way of finding a straight line equation. I don't know if you are familiar with this. Y minus y1 is m times x minus x1. That is the other equation. And we know now that m, the gradient, is 27 over 2. Now, in order to get the actual equation, we need the point of contact. Now, guys, we know that the x value of the point of contact is a half. We still need to find the y value of the point of contact. I'm going to end this live soon, so I'm not going to take guests now. Now, to get the y value of the point of contact, we need to substitute this value into the actual equation. All right, so y value of point of contact is y equals, and now we have the equation of the actual graph because we found our a, b, and c values. So if we remember from the previous question, the a value was, where am I now? Oh, I'm on the wrong page. That explains a lot. A was -2, B was 3, and C was 12. I saw someone saying that I made a mistake. I'll check that now. Oh, there's so much going on outside this window. I'm struggling to focus. So A was -2. So negative 2x cubed, remember, I'm just writing the equation of the graph quickly, plus bx, so plus 3x plus 12. That's the equation of the actual function. So to get the y value of the point of contact, we have to sub in the x value of the point of contact. So we're going to do negative 2 times a half cubed plus 3 times a half plus 12. All right, and that should then give us, let's quickly check what that is. Negative 2 times a half cubed plus 3 times a half plus 12, and that is 53 over 4. Sure, there's so much going on outside. Oh my goodness. Okay, so the point of contact is the point half and 53 over 4. I just want to check, guys. I almost feel like that is not right. Let me just double check my answers here. Check here. Oh. Okay, sorry guys, I'm going to have to cut off here now because I've lost my page and I'm a bit flustered. I'm just going to check this, I think, and my baby is at home now. I think that I might have made a mistake somewhere here. I'm going to finish this off and I will put it on YouTube. Sorry guys, but yeah, I hope that this has been helpful. Thanks so much. Sorry guys, but yeah, I hope that this has been helpful. Thanks so much.